Hello guys, welcome back to another video of Becoming Code Expert. In this video, we will be dealing with bitwise right shift and left shift. First, let me teach you about bitwise right shift. In bitwise right shift, what we do is we take an integer value and this will be converted to binary, and all the bits will be shifted towards the right by a places, and then this binary digit will again be converted to integer, or we can also call it as decimal, and then this will be the output. So first let me take an example of the number n is equal to 10, and the first step is to convert it into binary. I have already taught you about converting it to binary in the previous video, just check it out. So on converting this to binary, we will be getting the value as 1010. So this binary value is represented with 4 bits. Usually any binary value will be represented in 8 bits. So this will be taken as 0000 and 1010. And here the next step is to do the left shift. The next step is to do the right shift. So I am right shifting this number by 1. So what happens here is since we are shifting this number, that is 1010, to the right by 1 bit, each of these bits will be moved to one place right. So this will be moved here, and this will be coming to this place 1. This will be coming to the last second place 0. This will come here, and simultaneously all of these will be placed in this bit. So this bit has come here. So now the question arises, what will be filled here? So in this place, we'll be filling whatever is in the next place. So it will be 0. And hence, this is the last step. And now we'll be converting this to integer. So it is, the number is 101. So this, on converting it to decimal, we get it as 5. And now let us see an example of a negative number. So first we have to find the binary digit. How we find the binary digit is, first we find the binary value of plus 10, that is 00001010, right? So when we find the negative number, we should check the presence of 1 from the last. So where we find 1 is in this place. So first we'll write the 0 as it is, and here we found a 1. So let this 1 be as it is. Till this we will be writing as it is, and then for the other numbers we'll be writing the opposite of what is already present. So the opposite of 0 is 1, and the opposite of 1 is 0, and here it will be 1 1 1 1. Since it is minus 10, we will be writing as minus 128. Only for this number, we'll be changing the sign, that is 128. And for the other numbers, we'll be just adding. So it is 128 plus 64 plus 32 plus 16 plus 0 plus 4 plus 2. This will give you minus 10. And now the other steps will be as it is. Now let us shift these bits. So 0 will come out, and here we'll have 1 1 0 1 1 1 1, and here also we'll have a 1. And on finding the integer number, we get it as minus 5. So this is all with the bitwise operation. And also we have a shortcut method to find the right shift. For example, I'm having the number as 10, and we are shifting this 10 by 1 place. The formula to find the resulting value is, should divide n by 2 power a. So what is a is this number, that is the shift, the number of shift, and n, this is the actual number. So this 10, we are going to divide it by 2 power. The value of A is 1. So this will be resulting as 5. Similarly, for minus 10, we'll be dividing it by 2 power 1. And this will be again minus 5. And now let us look about bitwise left shift. In right shift, we shifted the bits to the right, and in left shift, we'll be shifting the bits to the left. So for example, I'm taking a number A as 3, and the binary value of this will be 0, 1, 1. And this I have to shift by one place. So currently I'm having it as 0, 0, 1, 1. On shifting it to left by one place, I'm just moving this side. So it will be 1, 1, 0, and this 0 will not be added. And now the question arises, what should be filled here? So here we'll be filling it with a 0. So on converting this back to decimal format, we get the value as 6. Now let us do for a negative number. A is equal to minus 3. For this, the binary number is 101. And on shifting it by 2 places, I have the number as 101, and here let it be zeros. And now I'm shifting it by 2 places. I'm shifting it by 2 places, so it will be, this will be shifted to 2 places left. So it will be 101, and here it will be 00. And the decimal equivalent of this number is minus 12. And again, we have a shortcut for this. For right shift, we divided the number by 2 power a. And here we are going to multiply it by 2 power n. So a into 2 power n, this will be as 3 into 2 power 1, that is 6. And coming here, minus 3 into 2 power 2, which is minus 3 into 4, which is minus 12. Now let me explain it with the help of a code. First, let us do the right shift. So I'm giving the number as 10, and I'm shifting it by 1 bit. And next will be the left shift. I'm having a number as 3, and I'm shifting it to the left by 1 bit. Now let's execute the code. So as we had solved in the explanation part, we have already got the output. That is, the right shift of 10 is 5 and the left shift of 3 is 6. I hope this video was helpful to you. Subscribe my channel for more coding videos, and I'll see you in the next video. Thank you.